So let's think about the question properly. When a heavy bird, so let's say there is a line here, clothesline, and the bird is sitting over here. So when the line sags, we can assume approximately that it's like this. So these are the supports on the end. So there is a tension in this direction and tension in this direction. So assume that bird is sitting at the center. Now, when bird is sitting and it's heavy, so it has a mass. There is a force mg downwards. So to balance it out, there must be a force upward by this rope, which is normal force, which should be equal and opposite of weight of a bird. So this force here is provided by the tension. So component of tension. So let's draw the components. So if this is tension here, the upward component is T, and so let's say that this angle here is theta, then this is T sine theta. So since there are two sides, and so this one and this one, and both have components, upward components, such that they add up. So it is T sine theta plus T sine theta, and we are assuming the bird is sitting at the center of the rope. So in that case, they just add up and they're equal. So the mass times gravity is equal to twice tension times sine of theta. So let's find out exactly the value of theta. Theta is equal to sine inverse of weight divided by twice t. So that's the value of theta. Now, if line sags a lot, let's say it is something like this. In that case, this angle is large, theta. And then let's also write expression for t from this. So t is equal to mg divided by twice of sine theta. And you must know that sine theta increases from 0 to 90. So if theta increases, sine theta increases, and t will decrease. And if theta is small, t will be large, because sine theta is small. It means that if the line sags more, you need a little tension, while if the line sags little, you need higher tension. So it all comes from this equation here, and the knowledge that sine theta increases from 0 to 90. Thank you.